So some of the most important concepts in Git, which are basically introductory in nature, so that by the end of this session, not only you will be able to work with Git, but also you will be able to share your code with multiple people who you basically want to share your work with. All right, so that would be the intent of this session. So let's go ahead and see what is the agenda of this session. So guys, first we'll get introduced to Git, we'll understand what is Git, and then we'll move on to basically understand why is it used,
The
how
broadcast
it
is now
basically
starting.
works,
All
and what
attendees
are the
are in
different life cycle
listen-only mode.
stages in Git. Once we're done with that, we'll move on and talk about some of the most common Git commands that you will be using every day while you're working with Git.
Git
Okay,
in 60
so guys,
minutes.
this is the agenda for
Within
this
this
session.
session,
I
we will
hope
be
it's
going through
clear to
some of the
you.
most
So now
important
let's move on
concepts
and start
in
off
Git,
with
which are basically
different
introductory
types
in
of
nature,
version
so that
control
by the
system
end
out
of
there.
this
So
session,
before
not only
understanding
you will
what is
be
Git,
able
we
to
should
basically
basically
know
know, but also
you
you
know
will
the
be able
different
to
types of
share your
options
code
which are
with
available out
multiple
there, and
people
why are we looking out for,
who
or
you
why
basically
are we
want to
choosing Git as an
share your
option
work with.
for version
All right, so
control,
that would be the
right? So
intent
guys,
of this
there are
session.
two
So
types
let's
of
go
version
ahead and
control
see
system,
what
and for
is
those
the
of you who do
agenda
not
of this
understand what
session.
version
So
control
guys,
is,
first we'll
version
get
control
introduced to
basically
Git, we'll
means
understand what is Git,
managing
and
different
then we'll
versions
move
of a
on
file,
to
right?
basically
For
understand
example,
why
you
is it
might have
used,
noticed
how
that
it
Google
basically
in
works, and what
2005
are the different life
looked
cycle
very
stages
different
in Git.
than the way it
Once we're done
looks
with
today,
that, we'll move on
right?
and talk about some of the
That's because there
most
has been a
common
lot of
Git commands
updates
that
to
you will be using
the
every day
Google
while you're working with
website.
Git.
When
Okay,
you
so
look
guys,
at
this
it
is the
from
agenda for this
past years,
session. I hope it's
and
clear to
now
you.
whatever
So
it
now
is
let's move
currently
on and
is
start
the
off with
latest
different
version of the
types
Google
of
website.
version control system
But
out
let's
there.
say if you want
So
to go
before
back and see
understanding
how
what is
Google
Git, we
was
should basically
2 years
know
ago, how is
the
that
different
possible if
types
you
of
would have maintained
options
a
which are
version
available out there, and
history
why
of your
are we
files,
looking
it
out
would have been
for,
possible
or
like
why
that.
are we
But
choosing Git
just
as an
so we do
option
not
for version
manage it
control,
manually,
right?
just so
So
we
guys,
do not have
there
to
are two
do
types of version control
version
system, and for
manually,
those
we
of you who
basically
do
make
not
use of a
understand what
version
version
control
control
system.
is,
So
version control
you
basically
might
means
wonder, why would I
managing
want to
different
look at a
versions of a file,
website which was
right? For example,
basically created 3 years ago?
well, the reason for that is it could be that whatever feature that you are working on today, that feature has stopped working altogether, right? And it could be that, let's say, 3 or 4 days ago, your website was working perfectly fine. So it makes sense if you want to revert to the code which was there 3 4 days ago, rather than going ahead and understanding what is wrong in the code and then fixing it onto your system. So that is why what we do is, when we are dealing with code specifically, we basically follow a version control system in which each and every change that we do on any file of a project, of a code project, is basically tracked. So that's what a version control system is, right? Now when we talk about the types of version control systems which are out there, there are two types. One is the central version control system, and the other is the distributed version control system. So let's go ahead and understand what is the difference between the two. So when a developer has, whenever you're working on a project, there are multiple people who are working on that project, right? For example, the Intellipaat website, it's not created by one developer alone. There are multiple developers who are working on this website concurrently and then doing the changes. So if I were to make it more relatable to you, for example, you use Gmail every day, right? You might be using any other website every day. It's not the work of one developer. There are multiple people who are working on that product, right? And each person is in charge of a different component in the website, right? But all of them are basically uploading their code at one place, right? And this one place is basically where all the versions of the files are managed. So when you're dealing with a team who is basically making use of a centralized version control system, in that case what happens is no file is saved on their local system, right? So what you have to do is, let's say you have to, there are 1,000 files in a project, and what you have to do is, let's say you want to change the logo. So if you're working in a distributed version control system, all you have to do is download that one file where you have to make the change from the central server, make the changes and upload it back over there. Okay, so this is what a central version control system is, that you have a central place where all the code is present, and all you have to do is you have to download the file that you want to work on that file and upload it again. And similarly, there are other developers as well who download their own files respectively, work on them and send it back to the central server. So this is what a centralized version control system is. Then you have something called as a distributed version control system. So what happens over here? So in a distributed version control system, there is no one central place where all the code is stored, right? So what happens is, if you want to work on the website, first you will have to download the whole repository of the website to your local system, and then you can only work on the file which is present in that repository. It's not like you can download one file, work on that one file, and just upload that file again, right? Now you would wonder, in that case the centralized version control system is better, right? So why do you need a system like this which makes it more complicated? Well, the answer for that is that when you're working with a distributed version control system, first of all, the dependency with the remote repository, which probably could be on the internet or probably might be on the network of your office system, is basically snapped off. All you have to do is download the repository which is there in the remote repository once, and then you start working with your code. And when your code is done, only then you sync your local repository with the central repository. What do I mean by sync? Let's say you have to work on 4 files to get a change done on a website. So what you will do, first you will download the remote repository on your system. Now this remote repository has a replica of it on your system where you have all the files present, right? So now you can work with the files that you want, and once your changes are done, you will save all your work on the local repository. And once the work has been saved on the local repository, all you do is sync the local repository with the remote repository. So in this case, your interaction is just happening once with the remote repository, or twice with the remote repository, once to download it, and the other time when your work is complete to upload it to your remote repository, and that is it, right? So with this, even if you do not have an internet connection, even if you're not connected to the remote repository, it's not like your work will stop, right? You can still work on it because your code is now available on your local system, and you can do whatever you want with it, right? Secondly, it also allows you to run a replica of the website on your local system, because with the one single command you can have the whole code base on your system, which you can run on your system, see how the changes are being reflected on the local system, and only once you understand everything is working perfectly fine, then you upload it to the remote system. So you can do you can understand how the changes that you have done are working in combination with the other code components which are there for that website, right? And hence it gives you more flexibility in terms of testing on your local system. But in case of centralized version control system, you had to integrate everything to the remote repository, and probably from the remote repository you will push everything to the testing server, and then only you could test it, right? Or you will have to download each and every file on your system, make the changes, and then upload only that file to your central repository. But again, in that case, like I said, there were a lot of interactions with the remote server, and at the same time, it's not that secure, because if you have to do back and forth, you can do back and forth with your local repository in the case of distributed version control system. But in this case, the back and forth or the editing of files will happen directly on the remote repository, which can be something that you do not want. Okay, so that is why distributed version control system is preferred. So let's read about the features about it. So in distributed VCS, you do not rely on the central server, like I said. So you don't need not have a dedicated connection to the central server all the time. You just need it once to download the code files on your system. Second thing is, every developer has their own copy of the code, right? Which is a good thing. Third thing is, this also copies all the past version of the code on your local system too. So let's say you want to go back to a code which is there 4 days back. 4 days back, there was a change on the website which is working perfectly fine, but with your changes, that code has stopped altogether to work, right? So if you want to go back to the previous version, that previous version is also available on your local system. But in case of distributed version control system, you just have the current copy of the file. In case you want the previous copy, you will have to again ask the server to give the previous copy to you, and only then you would get access to it. So that is again a demerit of centralized version control system, right? and this would be the main difference between centralized version control system, which is CVS, versus the distributed version control system. Alright guys, so now let's go ahead and understand what is Git. So guys, Git is basically a software which helps us in doing version control, right? And it's a distributed version control system. So we have already understood what a distributed version control system is. So it's a distributed version control system which basically helps us to version code files. Okay. Now, if you go by the definition, it is used for tracking changes in computer files or the code files, and also coordinating work. So any project or any product, like I said, when you work on it, it's a team's effort. It's never one person who handles the whole product. It's always a team effort, and Git basically promotes collaboration, right? So if you are working on a project, there can be multiple people who will be basically working on that project. Moving forward, now let's go ahead and talk about the Git lifecycle. So now that we understand what a distributed version control system is, we understand that we are going to discuss about Git, which is yet another distributed version control system. We understand the advantages of using it. Now let's go ahead and understand how does Git basically work. So when we talk about the life cycle of Git, to sum it up quickly, there are three stages in Git through which a basically a code file goes from, right? So when you start working in Git, you basically start off to work in the working directory. So any directory that you start to work off in, that's basically your working directory. Once your work is done, what you do is you stage your work. You make it ready for uh, being saved on the version control system, right? So you kind of simulate all the files, or you basically promote all the files which you want to be you want to be saved in the version control system. For example, there could be 10 files that you're working with, right? For example, some could be input files, some could be output files, right? And some could be the main code files that you're writing in your working directory. But when you talk about saving your project, you want to talk about saving your code. Actually, you will not be saving the input and the output files. You will only be saving the main code files which are there in your working directory. So when you are basically going from a working directory to the staging area, what you're doing is you're selecting the files that you want to save in the version control system. So when you select those files that you want to save, that becomes the staging area. So in the staging area, basically put the files that you want to go ahead and save in the version control system. And finally, what you do is you save them. And the saving term or the saving process is basically called git commit. All right. So let's go ahead and understand these lifecycle stages one by one. So first of all, we start off with the working directory. So any directory which has your code file in it and which has git initialized in it is basically called the working directory. If I were to quickly give you, a glimpse, let's say I go to my terminal and let's say I create a directory. Let's say the directory name is learn. Okay, I go inside learn, and inside learn, what I do is I do git init. So what does git init basically means? Git init basically means that I've initialized a git repository. Now once I initialize a git repository, this folder learn has now become the working directory for me, right? So it doesn't have anything right now, so I can put some output files here. I can put some input files here, and then I can put some code files here, right? Now, these input files and output files I don't want to save. I just want to save the code files. So the way I can save the code files is by typing, or by staging the code files. And the way I can do that is using the git add command. Okay, so we'll be discussing more about it as we move along. But yes, so just to be clear what the working directory is, once you initialize Git, this folder where you initialized it, it becomes your working directory, right? So the place where your project resides in your local disk is your working directory. This project may or may not be tracked by Git. For example, if I have done Git init, this is being tracked by Git right now. But let's say you are creating a new project and yet you have not done Git init. Okay, so still in that case, technically that's your working directory because you have all your files over there. So once your project is probably at a stage where you feel it has to be shared with someone or it has to be uploaded somewhere, in that case, even if you do Git in it, in that case as well, it will be called as a working directory. Okay. Uh, by so the project can be tracked by Git by using the command git init, so that I just showed you. Once you start working on a folder, you just type in git init, and then that folder becomes initialized and that folder becomes your working directory. And by doing git init, it automatically creates a .git folder. So over here right now, if I do an ls, you are not able to see a folder called .git, right? So if I do ls-a, you can see there's a folder called .git. So this is a hidden folder in your working directory, and this hidden folder basically has all your settings. It has all the versioned files that you will never see when you're working in your working directory. Your working directory is always clean, and all the settings of Git, all the versions that are stored in Git are stored inside the .git folder. If you accidentally delete the .git folder, your Git version control system is done with. All your version files will be deleted, all your logs will be deleted. So that's why this folder is very important, and that's why this folder is hidden. Okay, so that's about the working directory. And then you have the staging directory, guys. So staging directory is basically the directory where you set which files you basically want to save in the version control system, right? So I gave you the example of having a lot of files, but among those files, let's say 3 or 4 files are the main files that you are the code files that you want to store as in your project repository. So for saving them in the staging area, what you do is you use the git add command, right? And by using the git add command, you basically specify which files are going to be tracked by Git specifically. Okay. Then you have something called as commit. So commit is the final stage of the file in a final lifecycle stage, of a file being saved on your local hard disk. Wherein, when you type in git commit, whatever files you have staged in the staging area will now be saved in the Git file system, locally, and that is possible using git commit. So if I were to explain the whole process to you using a diagram, so first thing what happens is you are in a program workspace. In this program workspace, what you do is you initialize a repository using the git init command. Now this git initialized working directory, where you complete all the code files, and then what you do is you specify all the code files that you want to save, and then that becomes the staging area for you. And once the staging area is ready with all the files that you want to save, you pass in the git commit command and the files get committed to your Git repository. But is this the end? So we were talking about the fact that Git basically promotes collaboration. So let's understand how that is done. So once your files are now committed to your local repository, what happens after it? How do we collaborate it with the team? So that's when the concept of GitHub comes. So GitHub is basically the remote repository of the distributed version control system that we were learning about. So in distributed version control system, as you know, you had a remote repository, then you had a local repository, and the developers used to work in the local repository. So GitHub is going to be the remote repository in this case. So besides GitHub, there are a lot of other projects also that you can use. For example, there is something called as Bitbucket. There is also something called as uh, GitLab. There are a lot of other projects as well, right? But all of them basically work exactly the same, right? From a developer's perspective, from a DevOps architect's perspective, all the commands are going to be the same that you are going to learn today as well for Git. It's just that the remote repository can be a different software where you are uploading. Okay, moving forward, now let's understand how does Git basically work. So let's say I have a folder, I have this working directory where I have different kind of files. I have some HTML files, I have some JavaScript files, I have some JSON, I have some CSV, I have some XML. So this project folder, first I initialize, I stage all these files that I want to save, and then what I do is I pass in the git commit command. Now, when I pass in the git commit command, what happens is all these files will now be saved inside the Git version control system. And Git, what it will do is it will assign it a commit ID. Okay. So this circle that you see here is basically a commit ID. It's basically a pointer to all these files which you have just created or which you have saved in your Git file system. Next, what happens is, let's say you do some update to your code. Let's say we added a CSS file over here. So the moment you add a new file and you save it again to Git, what Git does is it again creates a new commit and it again gives it a new ID. So mind you guys, you already had a commit ID in place and this is always going to be there. It's not getting deleted anytime soon. This will not be modified. Always a new commit will be created, right? And in this new commit, the changes will be saved. So mind the language that I'm using, it will only save the changes. So these 6 files that were there, these 6 files are there in this commit. So when you add or modify anything, only the modifications are now saved in the new commit that you have, right? You don't have all the files saved all together again. So with this concept, what happens is you also save space, right? So you save space because time and again you're not saving all the things again. What you're doing is you're only saving the changes. So in this case, the changes are the CSS file. So only this CSS file will be saved in the commit. But when you talk about the whole project, that project is going to be a combination of this commit ID and this commit ID. Okay. Now, because this project is going to be a combination of a lot of commits, what happens is you put all these commits on a branch. Okay. So what is a branch? A branch is basically a logical or a sequential straight line which has sequential commits on it. And whenever you want to see your code, what happens is your code always is on the head, which basically is the latest version of the branch. So right now, if I want to see what all files are there in the project directory, what I'll do is I will do an ls, and the ls will always happen on the head of the branch. So head is always pointing to the newest commit which has happened on the branch. So when I point to the head, what happens is I see the changes, and along with the changes, I also see the files which were there in the previous commits. Okay. And to logically basically go ahead and have a visual representation for it, we basically have a branch on which all the commits are basically arranged. Moving forward, this branch by default is created, and this branch is called the master branch. So no matter which Git software you might be using for the remote repository, or no matter which product you're developing using Git, you will always have a master branch, right? And when I say a master branch, you can have other branches as well. But in case if you don't have other branches, you will always have the master branch. The master branch is a default branch which is present in all the Git repositories. Okay. Okay, but why do we need a branch? So I told you for the visual representation, for arranging the commits, you need a branch. But is that the only use case of having a branch, or are there any other things as well that you can do with the branch? So yes, there are other things as well that you can do with the branch, and let's go ahead and understand that. All right, so why do we need a branch? So, guys, let's say you are a developer, right? And what you do is you basically have been hired by someone who has already created a prototype of the project. Let's say I'm a developer, created my project, and now I feel that it's time for me to scale up. It's time for me to basically get the project running faster. And so, what I do is I hire a bunch of developers. So how do I make them collaborate to my project? So the way it works is, what I do is I put my project on a master branch and I put it on GitHub. Now, I don't want the other developers, since I do not know the capability of other developers. Let's take a scenario here that I do not know how well the other developers know how to code. So what I do is I don't give them the access to my main code. I basically create a copy of the code and I tell them all the R&D, all the research and development that you want to do it in this particular copy of the code, right? And when you think the task that I've given you is complete, get it reviewed by me, and then what I'll do is I will basically take the changes that you have done in that folder and I will integrate it with my main code. Okay, let's take this scenario. So in this scenario, the main code is basically the master branch. The copy of the folder or the copy of the main code that I give you is the feature branch, And what the developer will basically do is he will start working on this branch. So branch is basically a nomenclature, but in other words, it's basically a folder that you create in Git. So you have a master folder, and then you can create multiple other folders where other developers can work. So in this case, if I hired one developer, let's say I asked him to develop or change the UI of my homepage. So I add a feature A folder, which I say is this is the folder where the new UI will be added and worked upon by a new my new developer. So what I do is I create a new branch, copy the master branch code over here, and now this new developer starts working on this branch. Okay. So when his work is done, he commits the code into a new commit ID, which is 004. And once I review it, once everything looks good to me, what I do is I merge it with my main code, which is the master branch. So this is a very simple workflow of how collaboration basically works in Git. So since you have one developer over here, what you can also do is you can have multiple developers who can be working on multiple branches. So you have feature A branch, you can have feature B branch, feature C branch, feature D branch, and all the developers can then work in parallel for different features. And as and when their features are over, I can just merge it back to the master. And this is basically the crux of how Git works. Now let's move on and talk about some of the common Git commands that you will use in order to make use of Git.
Hello everyone, welcome to this session on common Git commands. Today in this session I'll be teaching you some of the commands that will be useful to you while you're working on Git. So let's get started. So the first set of commands that we will be learning will be basically how to create repositories in Git. After that, we'll move forward and discuss some commands which will basically help you to make changes in the files which exist in your Git file system. After that, we'll move forward and discuss some of the commands which will basically help you to sync repositories in Git. After that, we'll discuss some commands which will basically endorse parallel development in your Git project, and then move on to discuss some of the miscellaneous commands that you should know while you're working on Git. Alright guys, so this is the agenda for this session. I hope it's clear to you. Let's go ahead and start off with a session which is common Git commands. So basically we've divided all the commands that you could be used frequently or you will be using frequently among these four domains, right? The first domain is about creating a repository. So we'll be discussing some commands which will help you create a repository in Git. Then we'll be dealing with commands which can help you make some changes in Git. Then we'll be dealing with commands which will help you do parallel development in Git. And then towards the end, we'll also be learning commands which will help you in syncing your repositories. Okay. So let's discuss each of these domains one by one. So let's talk about how to create repositories. Let's start from the scratch, right? So our first, whenever you start a project, the first thing that you have to do is you have to go to your working directory and you have to do some code or make some code, right? So the first thing that I'm going to do is let me just switch to my terminal. Alright, so this is my terminal and I'm logged into an Ubuntu server. So what I'm going to do is I'm going to create a directory which is say called Devops. Okay, so let me create a directory called Devops and let me just cd into this directory. Okay, so I'm into this directory now. Let me just clear the screen. Now let us add some files. Say I add a file called nano. Let me add a file called 1.txt. Okay, and let us say hello world in it. So this is our first file. Okay, now let me add one more file. Let us add a file called nano2.txt. Let's say hello from Intellipaat. Okay, so this is a file that we have added now. Let's save this file. Okay, so now we have two files which are there inside a folder Devops. Okay, so this is not being tracked by Git as of now, right? But it is still our working directory. Now, for making it a Git initialized working directory, all I have to do is type in Git init and hit enter. Okay, and now we have a initialized Git repository in front of us. Okay, so
this is how you can initialize a directory in Git. So now you have created a repository in which you have your code, which will now be tracked by Git. Let's come back to our slides. So this is exactly what we wanted to do. We wanted to initialize a Git repository, and we have done that. We have added some files in that directory. Now let's go ahead and see what our next command is. So our next command is about knowing the status of what are the files doing in that directory. Are those files saved in Git? What is the status of that directory? And the command for seeing the status of directory or the files inside it is the command git status. So let us quickly jump back to our terminal. Let me just clear the screen. And now if I want to see like if my files are being if my files are saved in Git, what exactly is happening with my files. So what I do is I just type in git status, and I can clearly see that my files are right now untracked. Okay, why are they untracked? Because I've not staged them yet. These are just files which the Git is seeing that they exist in the directory, but they have not been added to my file system yet. So this is what Git is telling me right now. Okay, and it is also telling me if I want to track these files, all I have to do is git add and then the file name. So I don't want to do that right now. So let us go back to our slide. So this is what git status does. It basically gives you a status of your repository or of your directory. What are the files which are in the directory? I mean, what is the status of those files? Okay, so we got the status. Our next command is about adding. Right, so basically we have made some changes to our file, and now we want to add it into a repository. And for doing that, all I have to do is just go back to my terminal, and I'll say git add. I can either type in the name of the files. So say I want to track both the files, so I'll just type in 1.txt or 2.txt. You type this, or what you can do is you can just type in git add and then a dot. Dot means track all the files which are present in this directory. So I'll hit enter, and now if I do a git status, let me just clear the screen. If I now do a git status, I can see that my files are now being tracked. Okay, so my files are now being tracked. They are staged, right? So if you think about the life cycle, you were in the working directory. Now you are in the staging area. You have staged your files. You want these files to be saved in the Git file system. They're still not saved. They're still in the staging area. The next step is saving these files in the Git file system. And for doing that, the command is git commit. Okay, so how do you type in the git commit? You type in git commit, then you give a space -m flag, which basically means the message, and then you type in the message that basically would point to what you are basically doing in that commit. For example, in this case, since this is our first commit, we can simply type, let me just clear the screen, git commit -m. We can say this is our first commit, adding 1.txt and 2.txt. Okay, so this is what we do. We just hit enter, and now you can see that my files have been committed to Git. Okay, and now if I do a git status, now, you can see it says on branch master there is nothing to commit, working tree is clean. That basically means all the files which are there in this directory right now are clean. They are all saved in the Git file system, and there's nothing to worry about right now. Right? So now let's do a little experiment. What I'll do is I'll add one more file. Let me just create one more file, and let us name this file as 3.txt and type in test file inside it. Right? So now what happens? So if I do git status, you can see it will say that 3.txt is a file which is untracked in Git. Rest all the files which are there, it is not listing that because those are already saved in Git, and they are there's nothing changed to those files. Also, let us try by changing the 2.txt file, which is not listing over here, right? So what we'll do, we'll just do a little change to it. Let me just add 1.2 over here. Let us save it, and let me do a git status now. Let's see what happens. So if I do a git status now, it can see there is a modified 2.txt file, and there is an untracked file which is 3.txt. Okay, so this is something what you get. So any changes that you do to a file, it will be reflected in the status of Git. Now if I want the 2.txt file to be saved, I have to stage it again and then I'll have to commit it. Okay, that is the only way I can modify the 2.txt file. Okay, so let's come back to our PPT now and let's go ahead and see what is our next command. So our next command is about syncing repositories. So now we have committed the files to our local system, but how do we make it available to the world, right? So for making it available to the world, the first thing that you have to do is you should have a Git repository. Okay, so let me just jump on to my browser and then I'll show you how you can create a Git repository. So just give me a second. Okay, so guys, you just have to sign up on GitHub, and once you sign up, this is how your page would look like. Now what I want to do is I want to create a new repository. So on your left hand side you will see a button called new repository. Just click on that, right? And now let's name a repository something. So let us name it as DevOps and hyphen course. Okay, so our repository name is DevOps course and the type of this repository is public, and let us just now click on create repository. Okay, so our direct repository has now been created, and now what I have to do is I have to copy this link. This is a HTTPS link, guys, so I have to copy this link. Let us copy this link, and now let's come back to our PPT to see what exactly we have to do. Okay, so now to add files to this repository or to push files to this particular repository, first I have to add it in my command line. Now for adding this repository in my command line, I have to type in the command git remote add origin. Okay, this is the command git remote add origin and then the URL to the repository. So let us do that in our terminal. So I'm here. So right now when I'll commit, basically my 1.txt and 2.txt will be saved. My modified 2.txt file and my 3.txt will not be pushed. Okay, so let us see if that happens. So now what I'll do is I'll type in git remote add origin and then the URL of my repository. So the URL is this. Let me copy that. This is the URL and I'll hit enter. So now my files or my origin URL has been added in my command line, right? It has been saved in this Git repository, my command line that is working on my Git repository. Okay, so now let's come back to our slide. So we have executed this command. Let's see what our next command is. So our next command tells us how to push files to my URL, right? So the command is git push origin master, and see guys, this is the output for your command. Now when you type in this command git push origin master, it will ask you for your username and it will ask you for your password. So let us do that. So let me come here and let me type in the command. So the command is git push origin master. Okay, I typed in this command. It is asking my username. Let me enter my username. It is asking my password. Let me enter my password. I'll hit enter. And as you can see, it is pushing the files. And now my files have been successfully pushed to my repository. Let us check that. Let us come back to our browser. Okay, and let us refresh the page. So as you can see, it just says 6 minutes ago the files were committed to the repository and now they have been pushed, right? And over here you can see the message of my commit, which was first commit adding 1.txt and 2.txt. So you get the message over here. Here are the files, so you can see the changes or you can see the content of the files as well. If you click on 1.txt, my 1.txt had the content hello world, so it's being reflected here. Similarly, if I want to see my 2.txt, I can see that it says hello from Intellipaat, right? So everything is here, everything seems to work fine. And again, what I can do is now if I do a git status, you can see that there are two files which have not been added. So what I'll do is let me first make or let me add first the 2.txt file, that is a modified 2.txt file, into my git repository. So what I'll do is I'll type in the command git add 2.txt. Let me hit enter. So now this file has been staged, right? So if I do a git status now, I can see that this file is now staged. Okay, but this is still untracked, so we'll deal with this later. Okay, so now I have a modified 2.txt file and all I have to do is git commit, and now I'll specify the message as modified 2.txt. okay, so this is the message that I'm passing. I'll hit enter and now my file has been changed, but these changes have now been done to my local repository, not to my remote repository. So if I come back to my browser and if I refresh, you can still see the file which was added.to.txt. It still says hello from Intellipaat and it was committed 8 minutes ago, right? So it still is not added to my remote repository. Now to add it to my remote repository, all I have to do is git push origin master. Okay, I'll hit enter. It'll ask me my username. I'll provide the username and the password. And now my files are being pushed to GitHub. It has successfully done that. And now if I do a refresh over here, you can see that it says that 2.txt was committed a minute ago, right? And you can see the message over here. It says modified 2.txt, right? And this is exactly what we did. So we have added the second file as well to our remote repository. Let's add the third repository file as well, which is the 3.txt over here. So we'll do a git add dot git commit -m adding 3.txt, and now we'll do a git push origin master. We'll give the username, we'll give the password, and now my file has been pushed. And now if I do a refresh here, I can see even 3.txt has been added with the commit message adding 3.txt. Okay, so guys, this is how you can push your files or you can sync your remote repository to your local repository. Okay, so this was the command for that. Let's move forward now and let's check whether this step I've already done. So basically you can see that I have now synced my local to my remote repository. I have you as you can see in the browser. Okay, now let's go ahead and see what our next step is. So our next step is to basically show you guys how you can clone a repository. Okay, so this is when I have basically I have pushed my local repository to my repos repository. Now say you are another developer who wants to work on this code. Now how can you work on this code? All you have to do is click on clone or download and just copy this link. Okay, copy this link, go to your terminal, right, and let me create a folder, say test over here, and let me create a folder called test over here, and let me go inside the test folder. Okay, now what I'll do is I'll type in the command git clone and I'll give the URL and I'll hit enter. Now what it has done, it has successfully copied the directory over here. So if I do an ls, I can see that the directory has been copied or my repository has been copied to my local. Okay, and the awesome thing about this is now if I go inside DevOps course, the directory, now over here I don't have to basically add a remote origin, right, because you have cloned the repository. So this directory automatically knows where if I push any file, where it has to go. For example, if I create a file, say I create a file nano4.txt, I say test file for clone. Okay, I'll say that, and now what I'll do is I'll add this, I'll commit this file, adding clone file. Okay, I'll hit enter. So my file has been committed, and now I'll do a git push origin master. I'll give the username, I'll give the password, and as you can see my file has now been pushed automatically. Okay, so if I do a refresh here, 4.txt has automatically been added, and I did not do a git remote add origin even if I am in a different directory. Okay, now let me show you what I exactly mean. If I create a folder, say I create a folder called test. Okay, test exists. Let me create a folder called hello. Okay, and if I go inside hello and if I do a git init, say I did a git init, and now let me say create a file called hello world.txt. Let me add any arbitrary text into it. Now if I do a git add dot and if I do a git commit and I'll say let's adding file. Okay, so the file has been committed. Now if I do a git push origin master, it'll give me an error. See, it says origin does not appear to be a git repository. Why? Because I'm in a separate directory right now. Okay, now if I do a cd, I go inside test, which was my first directory where I created all the files. So over here, if I do a git push, if I add a file, say, uh, let me first uh, pull everything. Okay, so because the git pull origin master. Okay, 1 second, guys. Okay, so I think this is now the repository. Okay, so the repository was DevOps. So let us go into inside DevOps, and let me just create, or let me just say git pull origin master. So this was the directory where we first created our code. Okay, let me hit enter. So now it has, as you can see, it has added 4.txt to it, because earlier we added in a separate folder, right? So now it has created 4.txt inside it. It has added 4.txt inside it. And if over here you can see, I have not specified what origin is. It automatically knows what origin is. Why? Because DevOps is a Git initialized repository. Okay. Similarly, when I said that hello is a Git initialized repository, but in hello I'll have to specify what is the origin of that repository, right? But if I do a git clone, as I did in test, right, I went into test and I did a git clone of the DevOps course. When I do a clone, it automatically copies the parameter as well as to what my origin repository is. Okay, any files that I add, if I push it on origin master, it will know where exactly it has to go. Okay, so this is how git clone can be helpful to you. All right, coming back to our slides. So now we know how to clone a repository in Git. We also saw how to pull files in Git, but let me show you again. So basically what we want to show you is that say you are inside this folder, DevOps course, which is the same repository as what you have. Let me just duplicate this session. All right, so this directory, which is DevOps, is pointing to the same repository as DevOps course. Okay, now if I do an ls here, I can see that there are 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. Similarly, over here I have 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. What I'm going to do is, let me add a file from here. So nano 5.txt, and let me say test file. Okay, I've added it. Let me say git add dot. So I've staged the file. Let me commit the file. Test. Okay, I've committed the file, and now let me push the file to my remote. So I'll enter the username, the password, and now my file has been pushed. Okay, so if I have updated my remote repository, this local repository of mine will not get automatically updated. As you can see, it will not get automatically updated. If I do an ls over here, I can see there are 5 files, and if I go here on my remote repository, if I refresh, I can also see here are 5 files. But imagine this to be one developer and this guy to be another developer. Now this developer will not have the updated files till he does a git pull. Okay, so if he wants also the updated files which have been put on my remote repository, all he has to do is he has to type in git pull origin master, hit enter, and now the files will be updated in his system. Okay, so if I do an ls now, you can see that 5.txt file has now been added to this directory as well. Okay, so for coming back to our slides, so git pull helps you in updating your repository to the latest commit which is available on your remote repository. So that is what git pull is all about. And the difference between git clone and git pull is, like I told you guys, git clone is basically used when you want to copy the whole repository at your local system. But if you want to update repository when you're working in it, if you want to update all the files which are inside it, you can use git pull. In that case, git clone will not serve the purpose. Okay, moving forward, Now let's talk about branches. Now, as you can see, now we are talking about parallel development. Okay, and as we learned in our previous topics or previous sessions, that if you want to do parallel development, or if you want to assign code to multiple developers, you basically branch out, right? You create a branch in your repository and you assign that branch to the developer who would be working on the code. Okay, so let us see how you can create a branch in Git. So for creating a branch in Git, this is the command: git branch and then the name of the branch. Okay, so let us see if we can create it over here. What I can do is, let me just clear the screen. Okay, and let us say I create a branch which is something like this: git branch, and say I create the branch feature one. Okay, so the branch has now been created. Now if I want to list all the branches which are there, I'll just have to type in git branch, and I can see there are two branches in my repository now. One is called the master branch and the other one is called the feature branch. Okay, now any developer who wants to work on this code can basically work on this branch, and when he feels that his work has been finished, he can basically merge this branch to master. And merging means that whatever code you have added to feature branch will also be added to the master branch. Okay, don't worry if you're not understanding as of now, you'll understand as we move along. Okay, so I have added a branch feature one. Now if I want to delete a branch, again all I have to do is git branch hyphen d and then feature one. Okay, so it says deleted branch feature one. That's it. Okay, so now your branch has been deleted. Okay, and this is exactly what we wanted to do. Moving forward, now if you create a branch and you want to switch to that particular branch, the command is git checkout. Okay, so now let me create the branch again: git branch feature one. So I've created a branch, and what happens when you're branching? Basically, the last commit of your master becomes the first commit of your feature branch, whatever you have created. Whatever branch you have created, the last commit of your master becomes the first branch of your branch that you have created. Okay, so for example, in my master you can see that there are 5 files. So now if I go inside, if I do a git checkout into feature one, so basically now I have switched to the branch feature one, and if I do an ls over here, you can see there are 5 files. Okay, now what I want to do is I'll add a file. Say I add a file 6.txt over here. Okay, and I say hello world. Okay, and what I do is I save the file, git add dot, I stage the file, and now I commit the file, added to feature branch. My file has been committed, and now if I do an ls, I can see there are 6 files now. But mind you guys, this is not on my branch branch. Now if you want to see which branch you are on, just type in git branch, and you can see you are on the feature branch right now. Okay, now what I want to do, I want to check if my master branch also has these changes. So what I'll do, I'll just switch to my master branch, git checkout master. I'm on my master branch now, and if I do an ls over here, you can see that the 6.txt file does not exist here. Okay, reason being, my feature branch is isolated from my master branch. Whatever changes I'm doing on my feature branch, it will not get reflected on the master branch, whatever I do. Okay, and whatever I do on my master branch will not get reflected on my feature branch. It works vice versa. Okay guys, so this is a feature which you basically use when you want to do parallel development, so that no branch is it is interfering with each other. So now I don't care what my developer is doing on feature one. When he says that the feature is complete, I'll ask him to show me, and when he shows me the feature and I feel it's right, what I can do is I can merge it with my master so that it becomes available to the world. Okay, okay, all right, great. Now if I do a git status here, git status, one second, git status, it says on branch master, nothing to commit. If I check out to feature, yeah, so if I have switched to feature now all I have to do is I will type in git status, and it again says on branch feature 1 nothing to commit. Why? Because I've already committed 6.txt to it. Now what I want to do is I want to push these changes to my remote repository. So what I can do is git push origin feature 1. Why? Because now we are pushing the feature 1 branch. We are no longer pushing the branch, the master branch. We are pushing the feature 1 branch, right? And I'll hit enter. So it'll ask me the username. I'll hit that. It'll ask me the password. I'll put that and I'll hit enter. And now you can see my files are being pushed. And now you can see that feature 1 branch has now been pushed to feature 1 branch of my remote repository. So if I go to my browser now and I refresh it, you can see the 5.txt is still not visible here. Why? Because I'm on my master branch. I'll click here. I can see that I have a feature 1 listed over here. I'll click on that and now I can see that the 6.txt file is visible here and with my commit message which was added to feature branch. Okay, so I can again switch to my master branch and I can see that my master branch is clean. If I switch to my feature branch, I can see that my feature branch is having the 6.txt file. Okay, let's come back to our slides. Alright guys, so we now know how to switch to a particular branch. Now let's go to our next slide. Now we probably know all the commands through which we can probably start working on Git, right? This command is a very important command, which is git log command. Now what is git log command? Now git log command helps you to see the history of your repository, like what all have you done on your repository. Okay, now to see the history of a repository, the command is git log. Now let us go back to our terminal and let us just clear the screen. Now if I do a git log here, I can see the history of all the commits. Okay, so I can see that I am on my head is on the feature branch right now, right? And I can see that the last commit was this, when I added 6.txt to the feature branch. Before that I had a test commit. Before that I had a clone file that I added. Before that I had some other commit, 3.txt, 2.txt, right? So similarly I get everything. I get a history of everything that I've done so far, right? And these are all the commit IDs, guys. This is what we studied earlier, right? So if I want to say revert to this commit, all I have to do is just copy this commit ID and I have to type in git revert along with this ID, and I'll be able to revert to this particular commit. But we'll do that later. We're not doing that right now. We'll do that later. But this is the history of your branch. Okay, now if I want to see the history of master, this is the history of feature 1. Okay, let me just clear the screen and let me see where I am right now. So I'm on feature 1. So if we go to git checkout and then master and then clear the screen, if I do a git log over here, you can see that the head is now on the master and only the log of the master branch I'm able to see right now. Okay, I cannot see the log of adding the feature file. Why? Because I'm on the master branch now. So whenever you do git log, you always see the log of what branch you're on. Okay, so right now I'm on the master branch and that's why I can see all these logs. If I am on the feature branch, I can see all the logs of the feature branch along with the logs of master branch when the branch was when basically the moment I create a branch in my repository, it gets created from the master branch, right? So say I did 3 commits before I created a new branch. Those 3 commits will also be a part of my new branch that I've created. And if I go inside that branch and if I do a git log, I would be able to see those 3 commits in the log as well. Why? Because those 3 commits are also a part of those of that particular branch. Okay, so but the moment I do any other commits on master, those logs of that commit will not come in my feature branch. Reason being, now my feature branch is separate. All right, so I hope this is clear. All right, coming back to our slides, guys. So we now know how to see the history of our our git operations. Our next command deals with git stash. Okay, so what is git stash? So whenever you're working with multiple branches, there could be a point where you don't want to basically commit the file is basically still not complete, right? But you want to switch to another branch because you want to probably fix something in some other branch where you're having a problem, right? So basically it's about multitasking. It's about putting on hold the work that you're doing right now, completing the work over there, and then coming back here again and then starting with your work, right? So let me exactly first show you why do you need the git stash command. Okay, so if I'm over here right now, let me just clear the screen. Okay, so let us see where we are right now. So if I do a git branch, I can see I'm on the master branch right now. Okay, so what I want to do is I want to create, or let me just switch to my feature one branch, and let me create a file called 7.txt. Let me name it as stash file check. Okay, so I have created a file, but this file is still not staged, it is not committed yet, right? So I am on my feature branch right now. So if I do an ls, I can see 7.txt is here. Now if I change my branch, what will happen? Let us see. So if I do a git checkout master, and now if I do an ls, you can see the 7.txt file over here. Why can you see the 7.txt file? Because this file is not being tracked right now. It is not a part of any branch, right? Because it has not been saved yet, correct? So what I can do, so let me just come back to my feature branch. What I do, I'll just add, or I'll just stage this file. So let's see what then happens then, right? So I'll do a git add dot, right? And now the file has been staged, but it's still not committed, right? So if I do an ls now, it has all the files. Now if I check out to my master, and if I do an ls here, I can still see this 7.txt file. Now this can become a problem, or this might cause a confusion when you're working within branches or when you're working with production code, because you don't want this file to be here when you're on the master, right? Because you don't want your code to go haywire or cause a problem because of an extra file, or probably you changed something in 5.txt. Let me give you an example. Let me check out to my feature one. Okay, and let me go to 5.txt. So this is my 5.txt, and it's there in the master as well. Let me change the contents of this file. Okay, so I've changed the contents of the file. I'll stage it. Okay, and I'll do a git checkout master. Okay, I'm on my master branch now. I'll do an ls, and now if I do a cat of 5.txt, can you see these changes are also there in the master? I don't want that. I don't want that to be reflected over here, because my feature branch should be different from my master branch. Now to avoid this confusion, although this file is not saved on the master yet, right? It is just being reflected over here. Reason being, these files are not committed to your branch in your respective branch where you were working. Okay, so how can you avoid this? Now the way to avoid this is you would just check out, or you would just check out to your feature branch where actually you want this file to belong. Okay, and it tells you that these two files are there which this has been modified and this has been added. Okay, so it gives you a notification, which is good. Now what you'll do is you'll say git stash. You'll just say this and hit enter. Now what will happen? Now if I go to my master, git checkout master, okay, and if I do an ls, I can see the 7.txt file is no longer visible over here. Okay, and also if I do a cat on 5.txt, I can see this is the original file that the master should have, right? Now say I wanted to do something in my master branch. I'm done with that work. Now I want to get back to the work that I was doing in the feature branch. So what I'll do, I'll just do a git checkout feature one. I'm back here. I'll do an ls. So right now the files will be not saved. So if I do a cat.5.txt, it will still be the test file. It will still show me the committed version of the file. I mean, if I want to restore the files that I was working on, all I have to do is git dash and then pop. This is the command to basically come back to your working state. So I'll hit enter, I'll clear the screen, and now if I do an ls, I have 7.txt, and if I do a cat on 5.txt, I can see this is the modified 5.txt. So I'm now again in my working state. If I do a git status, it will show me that my files have been staged, but then they have to be committed now. Okay, so now all I have to do is I'll say git add dot, and now I'll commit these changes, committing stashed changes, and now these changes have been committed to my feature branch, right? And now if I do an ls, if I do a git status, I can see that my branch is clean, and I can now easily just go back to my master. I don't have to stash anything anymore. And if I do an ls, it is still isolated. Reason being, everything is committed to the branch now, and there is no dangling files here and there, which could confuse me with the files that I'm working in whichever branch I want. Okay, and this is why we use the git stash command, so that we don't have any confusions. The files don't get mixed up with the files of other branches, and we don't get confused. Okay, so guys, this was the git stash command. Let's see what our next command is. So our next command is git revert. Okay, so this is an awesome feature of Git. So let us come back to our terminal. Okay, so what I want to go do is I'll just do a git log, and I have all these commits over here, right? So I want to go back to my first commit where I just had my 1.txt and 2.txt. Okay, I want to go back to this commit. So all I have to do is I'll just click, or I'll just copy this commit ID, right? I'll clear the screen. I'll do a git revert, and I'll just paste that commit ID, hit enter. Alright, so let's go back to our terminal. Alright, so now for doing this, let us first see where we exactly are. So we are on the feature 1 branch. Awesome. So now we want to revert the changes, right? So for reverting the changes, the first thing that you do is you see the log. So right now the logs is that the last commit that was made, on which the head is right now, is this commit where we added these stashed changes. So this caused a problem in my code, and I want to revert this. So I want to revert this commit. So whatever changes I'm doing in this commit will be undone, right? Now for doing that, all I have to do is I'll copy this commit ID, okay? And before just doing everything, let me just do an ls, and I can see that I have 7.txt which I added in my stash changes, right? So what I'll do is I'll just do a git revert, and I'll paste the commit ID, right? So let me just take the commit ID from over here, done, paste it here, hit enter, and now you can see it will say your 7.txt will be deleted, and we modified 5.txt, remember, right? So my file which was modified 5.txt will also be reverted. So these will be the changes which will be committed once I revert from this commit. So I'm like, okay, so I want to do this, so I save it, and now if I do an ls, I can see that 7.txt has been removed, and my file also which I had modified has now been changed, and you can see the changes over here. So that 2 files have been changed, 1 insertions and 2 deletions, and this is it, right? This is what just happened. And if now I do a git log, you can basically just see that when I did git revert, it basically committed a new thing on my feature 1 branch. It committed a new file on my feature 1 branch with the message revert of committing stashed changes, right? And it says this revert commits 9A6090. So basically it undid the changes which I did in this particular commit. Now if you still want to go back to this commit and see what changes have actually been done, what you can do is, if I want to go to this commit, all I have to do is just copy this commit ID, and now I'll type in git checkout and then the commit ID. Okay, so now I'm in the stashed commit, right? So now if I do an ls, I can see that 7.txt is present, Right now, what I want to see is what all things did we modify. I think we modified 5.txt, so let's do a cat on 5.txt. So I can see it says test file 12, and here is my 7.txt, which I do. If I do a cat, it will say stash file check. Okay, now what I'll do is I'll say git checkout feature 1, so it will again return to the latest commit on my feature 1 branch. So I'm returned now. If I do an ls, I can see that 7.txt file is not there. If I do a cat on 5.txt, I can see that it has again returned to test file. So my changes which I did over here, that is, I changed file in my commit of stash changes, that is, I changed the file content to test file 12, and I created a file called 7.txt which I had stash file check. I had reverted this commit, and reverting means undoing the changes that you did in that commit, right? And it undid the changes that I did in that commit. So I don't no longer have 7.txt which I created, and I no longer have the contents of 5.txt to be the same as what was there in that particular commit. Okay, but remember guys, you still have that commit in your logs, and if you want, you can go to that commit and see what all things you want to fix, right? It's right here. But the head of the feature branch has now changed to a new commit, which basically has undid changes or undone changes of what was there over here. Okay, sounds great. So this was all about git revert. All right, moving forward, the next command is git diff. Now git diff basically helps us in understanding what all has changed, right? What is the difference between two files, or what is the difference between two commits, what are the difference between two files? You can all see that using the git diff command, right? For example, if I come back here and I want to see the differences between what I did over here and what I did over here when I actually committed the stash, so we can do that. Let us see how we can do that. So I'll type in git diff. Okay, git diff, and then I'll type in this commit id, which is my head right now, and this commit id, which I basically reverted. So I hit enter, and it will tell me that what all did change from both these commits, right? So it says that you have modified 5.txt. So there are two versions of 5.txt, a/5.txt and b/5.txt, right? So the a file was deleted and the b file was added, and it also shows the content, which what content was changed and what content was added, right? So if I am comparing the head with my previous commit, it says basically this file was changed and this file was added, right? And if I see over here, it says that there was nothing before and then we added 7.txt. Okay, now if I do the same by reversing the order of the commits, let's see what happens. So what I'm gonna do now is I'm gonna say this is the commit which I want to check the difference with this commit. So now you can see that it says that test file 12 was removed and test file was added. Similarly, 7.txt was removed and null was added. Okay, so basically this should be your newer commit and this should be your older commit, and then it will tell the difference according to that, right? Similarly, if I want to do this, so I want to first check if everything is fine. So let me do a git status. Okay, so everything is committed on my feature 1 branch. What I'm gonna do is I'm gonna change something in 4.txt file. Okay, so what I'll do is I'll do a I'll do a nano 4.txt, and let me change the file content to test file for diff. I'll save it. Okay, sorry. So alright, so let's call this file as test file for diff. I'll save it. Okay, the file is now saved. I'll do an ls. So now my 4.txt file has changed and I can see that in git status. Okay, but I want to know what exactly changed. So what I can do is I can do a git diff with my head. So head points to the committed version of my branch, and I want to check what is happening currently, right? What is the current So current in my current directory, I have not committed or I have not staged the file for changes. Right, my current directory is different from what is committed on the Git file system. So that is what I'm comparing right now. I'm comparing my committed my latest commit with what is there currently in my folder, that is dot. Okay, I hit enter and you can see it says that there is something which has changed in the 4.txt file. So there was test file for clone before, which now has been changed to test file for diff. And this is exactly what I wanted to check. So git diff is basically used to check the differences between two commits or two files. Okay, and this is exactly what we have checked right now. Awesome. So let us come back to our slides. So guys, this brings us an end to all the common Git commands that you could be using in your day-to-day life while you're using Git, right? In our next class, we are going to discuss the most important topic of Git, which is merging, right? Now, before going on to the next slide, I would request you guys, you practice all these commands once on your own. You will understand how things are actually working behind the scenes, right? I've showed you the syntax, I've showed you how it works, I've showed you the results. I want you to practice on your own as well. All right, so see you in the next class, guys, where we'll be discussing about merging. Have a good day ahead and goodbye.